In this lesson, we will be discussing how to evaluate the limits of exponential function. Let's start with the simplest standard form. If you are given to evaluate the limit as x approaches 0 of e to the power of x minus 1 all over x, how do we evaluate this? Let's start first with direct substitution. As x approaches 0, we'll have e to the power of 0 minus 1 all over 0. E to the power of 0 is 1. 1 minus 1 is 0 all over 0. This gives us indeterminate solution. So we have to go further to analytically evaluate this function. We are going to have the limit as x approaches 0 of e to the power of x minus e to the power of 0, because anything to the power of 0 is 1 all over x. And this will give us the limit as x approaches 0. They are in the same base, hence we take only their powers, x minus 0 all over x, and x cancel out x, we have 1, 1 minus 0. The final answer is 1. Now let's take a second example where we are given to evaluate the limit as x approaches 0 of e to the power of 3x minus 1 all over 2x. Now in evaluating this, you are welcome to pause the video and try your hands on it before watching the solution. So if we do direct substitution as x approaches 0, we are going to have e to the power of 3 multiply 0 minus 1 all over 2 times 0. And this will give us e to the power of 0, which is 1. 1 minus 1 is 0. And 2 times 0 is 0, which is indeterminate. So let's go further to analytically evaluate this function. We are going to have the limit as x approaches 0 of e to the power of 3x minus e to the power of 0, because e to the power of 0 will give us 1 all over 2x. And this will be, since they are in the same base, we are going to have the limit as x approaches 0 of 3x minus 0 all over 2x. X will cancel out x, so we have 3 minus 0, which is 3 all over 2. The final answer is 3 over 2. The next example, you can as well pause the video and try your hands on it. If you are having to evaluate the limit as x approaches 0 of 2 to the power of x minus 1 all over x, how do you evaluate this? There are several ways we can evaluate this, because this is a bit tricky. It's not in base E. You can use the L'Hopital's rule. You can use the sine rule. But the preferred method for me is writing this in exponential form. We know that for any positive value, let's say a, its exponential form will be e to the power of ln a, because e and ln a are inverse functions. Applying both will return the original value. So if we are having a to the power of x, the same will give us e ln a raised to x. which is the same as e to the power of x in a. Now we want to apply this concept. Instead of writing 2x, now we are going to have its exponential form. So we have the limit as x approaches 0 of e to the power of x ln 2 minus, this is the same, okay, minus 1. Let's take it one step at a time, all over x. And we know that this is the same as the limit as x approaches 0 of e to the power of x in 2 minus e to the power of 0 all over x. And we can see they are the same base, so we can have the powers. The limit as x approaches 0 of x ln 2 minus 0 all over x. And in the end, what we have here will be, because x will cancel x to give us 1. 1 multiplied ln 2 will give us ln 2 minus 0. So we have ln 2 as our final answer, and the value of ln 2 to one decimal place will be 0.7. And this is our final answer. Let's try another example. And for this example, as a matter of exercise, you can pause the video and try your hands on it before watching the solution. Now, if you are given to solve or evaluate the limit as x approaches 0 of 3 to the power of 2x minus 2 to the power of 3x all over x, how would you solve this? Now let's start again. This is not in base e, but we can rewrite this function to be in base e. We will have the limit so we are going to have the limit as x approaches 0 of, remember, we write this in base e to give us e to the power of 2x and 3 minus e to the power of 3x ln 2 all over x. If you are still wondering how we got that, remember, for any positive value, let's take the first positive value to be a. The exponential form will be e to the power of ln a. Alright, if a is to the power of x, it's going to be e to the power of ln x to the power of x ln a. So that is what we have done here. And since we are having this as the common denominator, if we rewrite this function, it's going to be the limit as x approaches 0 of e to the power of 2x then 3 all over x minus e to the power of 3x then 2 all over x. Now we want to rewrite this in the standard form. If we are able to write it in the standard form, where we can have e to the power of x minus 1 all over x, we will be able to solve. So for each term, we want to convert it to the standard form. And how can we do that? We can introduce minus 1 and plus 1, because if we have the limit as x approaches 0 of ln x ln e to the power of 2x ln 3 minus 1 all over x. This is the first part of the function, plus 1, because plus 1 minus 1 will leave the function the way it is. So plus 1, then minus e to the power of 3x ln 2, this all over x. So we have the second part of the function. So the first part is sorted. The second part, we want to rewrite it to be in the proper standard form, and the way to do that is to multiply this by minus. Alright, if we multiply the second term by minus, we are going to have, because minus 1 minus multiply plus 1 will give us minus 1, and minus multiply minus e to the power of 3x ln 2 will give us plus. So we can rewrite it to be in this form, so that we are going to have the limit as x approaches 0 of ln 2x ln 3 minus 1 all over x minus 1 minus e to the power of 3x ln 2 all over x. So we just rewrote this, and this is what we have. Now we know that for the first part, the limit as x approaches this, we know they are in the same base, so all we are going to have is 2x ln 3 minus 0 all over x, and s cancels out s. Now minus the second part, the same, we have 3x ln 2 minus 0 all over x, and here x cancels out x. What we are going to have is 2 ln 3 minus 0 will give us 2 ln 3 minus 3 ln 2 minus 0 will give us 3 ln 2. But how do we get the final value? Alright, we can use the logarithm laws, because 3 ln 2 ln 3 is the same thing as ln 3 raised to power 2 minus ln 2 raised to power 3, and ln 2 raised to power 3 is 3 times 3, which is 9. So we have ln 9 minus 2 to the power of 3 is 8 ln 8. Alright, so this is the same as ln 9 over 8, which will give us the final value will be 0.1178. If you understand what we have done so far, let's take the final example. You can try your hands on the final example before you watch the video to see if you are making progress. Now, if you are given to evaluate the limit as x approaches 0 of e to the power of x minus e to the power of minus x all over x. Let's try direct substitution and see if that will work. As x approaches 0, we are going to have e to the power of 0 minus e to the power of minus 0 all over 0. So this will give us 1 minus e to the power of minus 0 is still 1, which is 1 minus 1 all over 0, and 1 minus 1 is 0. all over 0, which gives us indeterminate solution. So let's go ahead to break this further. This will give us the limit as x approaches 0 of e to the power of x all over x minus e to the power of minus x all over x. We are just rewriting it. It's the same thing since we are having a common denominator, so we can as well split it this way. Now, in order to write this, the goal is to rewrite each of them in standard form, where we have e to the power of x minus 1 all over x. And if we are able to achieve this, then the solution will not be far-fetched. And the only way to do that is introduce minus 1 and plus 1 to the equation. So this will give us the limit as x approaches 0 of e to the power of x minus 1 all over x. So we have achieved the first part, plus 1, then minus e to the power of minus x, this all over x. And if we multiply the second term by minus, we will flip the function to be in a standard form. So let's go further. If we break this down, we are going to have the limit as x approaches 0 of e to the power of x minus e to the power of 0 all over x minus e to the power of minus x minus 1, right, which is e to the power of 0 all over x. Now let's solve the first part. For the first part, we are going to have the limit as x approaches 0 of x minus 0 all over x, which will give us 1. So the second part, which is e to the power of minus x minus e to the power of 0 all over x. Now if we try to break this down, we are going to have x minus x minus 0 all over x. We see this can cancel this, and this will give us minus 1. So if we combine both of them, we are going to see so combining both of them, we are going to have the limit as x approaches 0 of x minus 0 all over x minus x minus 0 all over x. This will give us 1 minus, this is minus 1, this cancels this, gives us minus 1. So we are going to have the final answer. Minus 1 minus minus 1 will be 1 plus 1, which is equal to, which is the final answer. If you enjoy the videos, please, we will appreciate if you can share, like, and subscribe to our channel. Thank you for watching.